Okay, free body diagram. Today we are discussing about the free body diagram. In many problems, it is essential to isolate the body under consideration from the other bodies in contact and draw all the forces acting on a body. What we have to do, if there is a number of bodies are available, we have to separate out one of the body. It means that we have to isolate that body and we have to draw separately that particular body, and we have to show all the forces which is acting over the body. For this, the first body is drawn and then applied force, then self weight and the reactions. What we have to show over the body, applied force, self weight and the reactions which is acting over that particular body at the point of contact. Reactions at the point of contact with other bodies. Such a diagram of body in which body under consideration is freed from all the contact surfaces and shows all the forces acting on it, including what? Reactions at contact surfaces, and is called as free body diagram. Now let us see some simple diagrams how to find out the free body diagram for that particular problem. Now if you see here, this ball which is resting over the ground, the free body required is ball. Now what we have to show, the self weight which is acting over the body, that is W, which is passing from the CG of that particular ball, as well as the reaction which is developing near the contact surface. Whenever any body is connected with or contacted with other body, the reaction will be developing at that particular point. That's why the self weight W as well as reaction R, that is we have to shown over this body, and this is nothing but what? The free body diagram of that particular problem. For this problem, the free body diagram will be like this one, and by using this free body diagram we are easily find out the whatever may be the unknowns. The W, that is the self weight, we may be known, and we have to find out the reaction R, and we have to use the equilibrium condition, that is summation Fy is equal to 0 or summation Fx is equal to 0. By using that conditions we may find out the unknown reactions. Okay, now let us consider this sphere again. It is connected with the string and supported by this vertical wall. The wall may be smooth one. The free body diagram required will be ball. Now look at here, what will be the shown over here over this body. First self weight is shown, then under this string there will be a tension developed due to the weight of this wall. That's why the tension will be shown in this string, and this ball is connected with the wall. That's why here the reaction will be developing. When any body is contact with any other surfaces, then there will be reaction will be developing at that particular point. That's why the reaction is shown. Here it is the free body diagram of this problem. By such a way we are easily shown the various forces acting over the body, reactions acting over the body, and the self weight of that particular body. Now if you see another diagrams, now if you see here, there is one ladder which is supported over here wall and a floor, and there is one weight. Let us consider one man is standing over that ladder having the weight of 600 Newton. Now here free body diagram required is ladder. Okay, now what we have to show over here, very first of all, the weight of that particular self weight of that particular ladder which is acting at the CG of that particular ladder. Second, external force which is acting over the body, that is this 600 Newton weight which is acting over the body, that is shown over here. Whatever may be the location, it may be provided in the problems. Okay, let us consider this one is at a distance of 1 meter, 2 meter, 3 meter from this any one of the end. Now here is another P force, external force, which is acting over the ladder. It is also shown over here. Now here what we have to show remaining is reaction. Now reaction due to this surface is smooth, it means that due to the surface is smooth, what we have to show? We have to show the reaction which is always normal to the support. Now let us consider this one is the reaction number 1, and here it is the also smooth surface, that's why only one vertical reaction is there. And reaction number 2, it is also normal to the support. It means that it makes an angle of 90 degree with here as well as over 90 degree over here, and that is nothing but what? Reaction R1 and reaction R2, which is shown in this figure. It means that for this free body diagram of ladder, what we have shown, the self weight, then external loads and reactions. By such way we are easily shown the free body diagram of that particular problem. Now here to solve this problem, what we have to do, summation fx is equal to 0, which is acting over that particular body, that we have to consider. Summation fy is equal to 0, that we have to consider for that particular body. Only what we have to consider for this body only, we have to consider summation fx is equal to 0, summation fy is equal to 0, or sum of all moment about any point is equal to 0. And we are easily find out the unknown reactions, unknown loads, that we easily find out. Now let us consider this problem. Now here if you see here, this one is the pulley. There is one weight is connected 600 Newton, which is resting over the floor, and another weight which is connected to this pulley having 400 Newton weight. Now here let us draw the free body diagram of this 600 Newton weight first. The free body diagram required for the block weight of 600 Newton. Now here over this block, what we have to show, very first of all, the self weight which is passing through the CG, that is 600 Newton. Next, which is the tension which is developing inside the string. Here this one is the string is connected over here. The tension which is developing inside the string is shown over here. Next, this block is rested over this floor, that's why here it is exerting one reaction, that is shown over here. And this is nothing but what? The free body diagram of your block weight of 600 Newton. Block weight of 600 Newton. Now if you want to draw the free body diagram of this 400 Newton, what will be happen? Now if you see here, this, let us consider this one with the free body diagram of the 400 Newton weight. Now the weight, now let us consider this weight is passing from the CG of that particular block, that is of 400 Newton. Now here this block is not resting over the floor, that's why there will not be any reaction, but it is connected with the string over here, that's why the tension which is developing inside the string, that we have to consider. The tension in the string will be shown over here like this one. This is nothing but what? The free body diagram of this 400 Newton block. By such a way we are easily draw a free body diagram, and we are simplify the problem, and we are solve that particular problem by using this free body diagram. Okay, now let us solve some simple problems which is based on the LAMI's theorem as well as which is based on the equilibrium conditions. An electric light fixture weighing 15 Newton hangs from the point C to the string AC and BC. The string AC is inclined at 60 degree to the horizontal and BC as at 45 degree to the horizontal as shown in the figure. Now if you see here in this figure, this is nothing but what? Your electric light fixture having the weight of how much? The 15 Newton, and it is hangs from the point C, and AC is the one of the string which is making an angle of 60 degree with the horizontal, and BC which is making an angle of 45 degree over here. Now here what we have to find out, the how much the tension will be developing inside the string AC and BC over here due to this weight of 15 Newton. That's why what we have to make the free body diagram of that particular string and this weight. Now if you see here, solution is, since the body is in equilibrium under the action of three forces, the problem can be solved by using the Lamin's theorem. Now if you see here, the free body diagram will be like this one. Now what we have shown, very first of all, this 15 Newton force is shown over here. Now here at point B to C, there will be the tension in the string. Let us consider tension BC over here. Now similarly in the string AC, the tension TAC is considered over here. Now here for our simplification, what we have to make the angle calculations. If we have drawn the axis like this one, as we know that this angle is of 90, this angle is of 90. Now here this angle is of 45, it means that this angle is of again 45 degree. Okay, if this angle is of 60, this angle is also 60 degree over here. Now for our simplification, what we have to make the angle calculations. Now let us do the angle calculations. Now here this 45 plus this 90, 45 plus 90, it becomes a 135 degree angle. It means that from the BC line to this vertical force, this angle will be of 135 degree. Now similarly over here, this side, this 90 degree plus this 60 degree, it becomes a 150 degree. What we have made, this 90 degree plus 60 degree, it becomes a 150 degree. Here this angle which is made with the vertical weight as well as the string AC. Now the remaining is one, what one? We have to find out the angle between this. How to find out this? Out of this 180 degree horizontal, this angle will be of 180 degree. Out of this angle is of 60, and here this angle is of 45. It means that we have to subtract from 180 minus this 45 minus this 60. Then you will be getting what? This remaining angle over here. Let us solve this one. 180 minus 45 minus 60. What will be getting? Angle of 75. That's why it is shown over here 75 degree angle. By such way, we are easily find out the angle between the forces. Now once we have found out this angle between the forces, as we know that one of the forces known to us, and these are the two unknown forces are there, and the angle between all these three forces are known to us. Now here this force system is having the three forces, concurrent coplanar forces are there. That's why we are easily solve this problem by using the Lamin's theorem. Now if you see here, now let us apply the Lamin's theorem. Apply the Lamin's theorem, and according to Lamin's theorem, what? This, first of all, this 15 Newton force divided by sine of angle between the other two forces, that is 75. That's why 15 divided by sine 75. Now next one, tension in the string AC, TAC. Now the opposite side angle is of this 135. That's why sine 135 over here. Again this TBC, the angle, opposite side angle is of 150. That's why TBC divided by sine 150 over here. And here, as we know that one sine rule is there, sine 180 minus theta is nothing but what? Sine theta. Now here, this sine 75 we have kept it as it is. Now here we are simplifying this one. What we have made the calculation, this 175-degree angle, if we are subtracting, how we have considered this sine 180 minus 45, sine 180 minus 45, that we have considered over here. It means that 180 minus this 45, it becomes a 135, sine 135. Instead of writing sine 135, what we have made? Sine 180 minus 45. It means that sine 180 minus 45 nothing but what? Sine 45. That's why it is written over here sine 45. Similarly, for this sine 150, we may write it as sine 180 minus 30. That's why this term will be sine 30 over here for our simplification only. But if you see here, now let us solve the terms. Now let us simplify the terms. Now we have to find out the force in the tension AC. Now let us take this sine 45 term to this side. What will happen? It makes multiplication over here. And now simplify the terms. Now calculate the terms. 15 sine 45 divided by sine 75. You'll be getting 10.998 Newton. That is the tension in the string AC. Now similarly, tension in the string BC. To find out the tension in the string BC, what we have to make? This term, let us take to this side. It means we are multiplying this term, this 15 sine 30 divided by sine 75. Now again make the calculation. This 15 sine 30 divided by sine 75. It becomes a 7.76 Newton. It means that tension in the string BC is 7.76 Newton. That is tension in the string BC. By such a way, we are easily find it out the tension in the AC string and tension in the BC string by using LAMI's theorem. If you have some confusion, instead of making this all this sine 180 minus theta or terms, you may take this value as it is. Your answer will be same. You may take this term as it is. Now let us check it out. If we are taking what we have take this sine 135 as it is to this side, what will happen? Put the values. 15 sine 135 divided by sine 75. Your answer will be 10.98. The same answer will be there, 10.98. There will not be change in the value. The same value will be getting over here. Similarly, if we are taking the sine 150 and if we are taking this term to this side, the same value will be getting. Now let us check it out. 15 sine 150 divided by sine 75. 7.76. The same value you will be getting over here. There is no any confusion if we are taking the same sign as it is to the calculation. Okay, instead of making this simplification, it is not be required. You may directly use this term for the calculation. You will be getting the same values for the same problem. Okay, now Let us say another problem. A string ABCD attached to the fixed point A and D has two equal weight 1000 Newton attached to the B and C. The weight rests with the position AB, CD inclined at an angle as shown in the figure. Find the tension in the portion AB, BC and CD of the string if inclination of the portion BC with the vertical is 120 degree. Now if you see here the figure, here this string ABCD is shown as per the figure. Here 1000 Newton weight is attached over here. Here for the point C also the 1000 Newton force is attached. Now here if you see here, it makes an angle of 30 degree with the vertical, it makes an angle of 60 degree with vertical. Here it is making an angle of 120 degree with the vertical. Now for such arrangement, what we have to find out the tension which is developing inside the string AB, BC and CD. And for these purposes, what we have to make the free body diagram for this joint B as well as for the joint C separately. And we have to apply the LAMI's theorem. Accordingly, you'll be getting the unknown reactions or unknown tensions in the strings. Now let us see. The given in the problem is the weight of the block, that is 1000 to the support B and C. Now we have to find out. Now let us consider this TAB is the tension in the string AB, TBC is the tension in the string BC, and TCD is the tension in the string CD. Okay, now free body diagram will be like this one, and we have to find out the angles. Now if you see here, for our simplification, this angle is 30, it means that this angle is of 30 also. And here also, if it is an angle is of 60, this angle is of 60 also. This angle is of 90, this angle is of 90. And by simplifying these terms, what we will be getting, the diagram will be like this one. This angle is of 30, this angle is of 20. Here it is 60, it is 60, and it is 20 over here. Now let us simplify the term. First, let us consider the free body diagram of the joint B. Okay. Now here there are the three forces. One is the weight, the tension in the BC, and the tension in the AB. And the angle between these, if you see here one by one, for the tension AB, opposite side angle is this one. How you will be getting this angle? Out of this total 180, if you are subtracting this 120, you will be getting this remaining angle is of 60 degree. That's why sine 60 is taken over here. Similarly, tension in the BC divided by sine of the opposite side angle is, now here out of this total 180, if you are subtracting this 30, what you will be getting, this remaining angle is of 150. That's why sine 150 over here. And last one, that is force of 1000 Newton. The opposite side angle is of this one, 30 plus this 120, it becomes a 150 degree angle over here. And now again here the simplification is done. You may take this value as it is also. Okay, now let us take this value as it is. This term to this side, what will happen? The sine 60 is multiplied with this 1000 and divided by sine 15 again. Now let us calculate this term. Let us calculate 1000 multiply with this sine 60 and divide by sine 150. This value will be 1732. That the same value, 1732 Newton. That is the tension in the AB. Now similarly for the tension in the BC, what we have to find out, this value we have to take to this side. It means that it will be multiplying with this 1000 you'll be getting. Now let us take this to this side. 150 divided by sine 150. But obviously this sine 150 get cancelled, remaining term is 1000 only. 1000. Okay, 1000 Newton. That is the force in the BC. Okay, by both the ways we are finding out this unknown tension in the BC and AB. Now here remaining is what? Now let us consider the joint C. Joint C. The tension in the BC and tension in the CD that we have to find out. Already BC tension is what we have found out. Now the remaining is only the tension in the CD. And this one is the 1000 Newton force which is acting over this vertical direction. Now here again we have to use the Lami's theorem, and according to Lami's theorem, now tension in the BC is equal to, or it is proportional to, the sine of angle between the other two forces. This angle will be of 180 minus this 60, you will be getting 120. That's why TBC upon sine 120. Now next is tension in the CD. Opposite side angle is of 120, that's why sine 120 over here. And for the 1000 Newton force, the angle between the opposite forces, that is again sine 120. Now what we have to find out, the TCD, that is the tension in the CD. Now let us take this term to this side. It is again multiplying with this term sine 120, and as we know that this is sine 120 and this is sine 120 gets cancelled. The remaining term is of 1000. That's why your answer will be 1000 Newton. The tension in the string CD is 1000 Newton. Okay, by such a way we are easily finding out the tensions in the string by using the Lami's theorem. Okay,